So let's do the normal distribution self-quiz. In-N-Out orders a large amount of potatoes for the fries. The shipment crate they buy, which contains a large number of potatoes, is inspected for quality by the manager. In general, the weights of the potatoes are normally distributed with a mean of 7 grams and standard deviation of 0.5 grams. So there's our mean, and there's our standard deviation. One potato is chosen at random from the box. For each, find and draw the probability that this potato weighs between 5.8 and 8.2 grams. So our mean is 7. So 8.2 is pretty close to that. It's about 1.2 away. Actually, that 8.2. It's about 1.2 away. And actually 5.8 is exactly 1.2 away also. So we should try to make this as symmetric as possible. It doesn't have to be perfect, but you want to aim for symmetry there. So something like that. Then we're going to do normal CDF. My lower bound would be 5.8. My upper bound would be 8.2. My mean would be 7. And my standard deviation would be 0.5. And then let's see what's the probability of that. So we're going to have second distribution, normal CDF, 5.8, 8.2, 7, and 0.5. We get about 98.984, 3 sig figs, 0.984. Weighs more than 8.2 grams. So we're right here at 7. And then here's 8.2. So just this part. So it's going to go 8.2 to E99. So normal CDF, 8.2, E99, 7, and 0.5. So second distribution, normal CDF, 8.2, E99. Everything else is the same. So we get about 0.008. The potato is considered too small by In-N-Out standards if it weighs less than 6 grams. Find a probability of selected potato is considered too small. So I gotta do less than 6. So here's 7. 6 will be over here somewhere. Anything less than this. So we're gonna go negative E99 to 6. So normal CDF. Negative E99 to 6. Everything else stays the same. Plug that in. Negative. We're going to use the negative, not the subtraction sign. E99. 6. Everything else stays the same. 0.023. 3 sig figs. So 0.0228 actually should say 3 sig figs. So we get that. Next, given that running selected potato is between 5 and 8.2, find probability is considered too small. So given that problem, given that it's between 5 and 5.8 and 8.2, find probability it's too small. So we're going to use the formula. Remember the formula sheet is this. A given B, which is probability of A intersection B over probability of B. So in this case, that's going to be probability of too small and between 5.5 and 8.2 all over probability of 5.5 and 8.2. Now, classic IB, I already know the bottom. We did probability being between 5.5 and 8.2. That's the very first question. 9.84. 0.984. Now, with this one, again, the top is the worst part. Too small in between those two. So let's do number line. Doesn't be perfect just to get the idea of what's happening. 5.5, 8.2. So we're between these two. And now, what's too small? Too small is less than 6. So let's say this is 6. Too small is less than 6. What's the overlap? This part right here. So the top is actually just between 5.5 and 6. So to do that, we got to do normal CDF. Lower bound 5.5, upper bound 6. Everything else is the same. Right? That's what's going on there. We're just trying to figure out What's the algebra between 5.5 and 6? So we need a calculator for that. So second distribution, 5.5 and 6. And we get 0.0214. Then we divide that, so we're going to divide that by that. Using our calculator and get that answer. I'm going to hit the second answer this time to show you, so that's the answer. Then we're going to divide by the answer we got before, 0.984. Again, I'm just going to use 0.984 because that's choosing that from a previous answer. So I can use a rounded version of it. And I got, ignore this one. I pressed it twice on accident. We get 0.0217. So there we go. One more. The manager selects 10 potatoes at random for the replacement. Find the probability that at least one will be considered too small. So selecting 10 potatoes with replacement. So this is all binomial. This is a binomial question. They want at least one. So remember, at least one is like I want at least one cookie. So that I get that. We can't point this point in the wrong direction. We can't have that. So we switch it. 1 minus x is less than 1. Because anytime you switch, you either gain or lose a sign. And then we can't have that. We have to go one below this because we have to need less than equal to sign. So 1 is less than equal to 0. So that's what I'm putting in my calculator. 1 minus binomial CDF. X is equal to 0. Or I need NPR. Well, my N is 10. My probability, what's the question? Too small. Did we find too small? Right here. Probability too small is 0.0228. And my R is 0 from right here. So I'm going to put that in our calculator. So 1 minus, scroll down, there we go. 1 minus binomial. So distribution, blah, 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 CDF. We're going 10 trials, 0.0228, right there. And then 0. Hit enter, and I gave up 0.206. So my answer is 0.206. That's the odds. I had extra credit on the self quiz. I would have given, right? Find the x to the fifth term of the binomial expansion. One of my favorite questions in the world. So remember, the way we do this is write what you know. I know for sure it's going to be an 8. First term will be an x. Second term will be a 2y. We want x to the fifth. So here's my x. You have to make that a power of 5. This power and this power, that has to be 8, so it makes this a 3. Which, if that's a 3, that makes this a 3. Now what we do is expand that. Figure out what 8c3 is. I'll do by hand. That's 8 factorial over 3 factorial, 5 factorial. Right? This is the formula right there. Remember, the way you simplify that, you get the bigger number on top, and you break it down until you get to the biggest number on the bottom. So it'll be 8 times 7 times 6 times 5 factorial. On the bottom, you will break down the smaller one, so that's 3 times 2 times 1. And you keep the bigger one alone. These cancel. 3 times 2 is same as 6. 8 times 7 is 56. X to the fifth. And -2, so remember that 3 goes to both. So it's -8 because -2 cubed is -8 y cubed. Then you multiply that together, you get something x to the fifth y cubed. And that'll be the answer.